Hello dear students, this is Devang Shah from LG Institute of Engineering and Technology under the LG University. Now today we are going to learn about the digital logic design, as the complete subject is based on digital signals, where those digital signals are going to follow a specific logic, and finally the design we have to make for a specific purpose, right? Or let's discuss about the digital logic design, how you can convert this hexadecimal number into a binary number system. Now further, if you convert this octal number into a hexadecimal number, you have to always convert that particular octal number into a binary number. So here our base is the binary, and then you have to take the group of 4 bits of binary number. You can easily convert this octal number into hexadecimal number. You can see this 635.27 octal number you have to convert into hexadecimal number. So your first job is to convert 635.28 that number into a binary number. Why? Because each digit of octal number is represented in form of 3 bits of binary. Once you convert it, then you have to take a 4 bits of group to convert into hexadecimal number. So you can see 635.27 is converted into a binary number, and then you have to take the group of 4 bits from LSB to MSB before the point and after the point, and you can make the group of 4 bits, and you can easily convert this binary number into hexadecimal number, right? So you can see 5 is represented as a 101 in a binary. See, if this 5 is converted into a 101, but once you take it in a hexadecimal number, you have to take 4 bits of groups here. So in a group you have 4 bits, 1101, and this 1101 is represented in a hexadecimal is a D. Same way here 1001, it's represented as a 9, so you have to take a 9, and this one further zeros you have to add the MSB. So your sequence is 0001, and that is represented as hexadecimal as a 1, right? So how you can convert this octal number into hexadecimal number? So here you must have to convert the binary number. Same way here, hexadecimal you have to convert into octal. So again, hexadecimal you have to convert into a binary, and then you have to take the group of 3 bits. You can easily convert into octals. You have to observe this particular example as A3B.7. You can convert into a binary form, and from binary you can convert into a octal form, right? So octal is nothing but the group of 3 bits. So from that we can convert one form of numbering system into another form of numbering system, right? Now based on this particular discussion, that is the introduction of numbering system, first part. Second, the conversion of one numbering system into another numbering system. We further discuss about the different examples of the conversion. Like binary, you have to convert into a decimal. You can see more elaborate way, like 1101 binary. If you have to convert into a decimal number, you can see the kind of 1101. So we'll have to start with the LSB, and we have to finish up to MSB, where first weighted binary is defined as a 2 raised to 0. So 1 multiplied by here 2 raised to 0, 2 raised to 1, then 2 raised to 2, and 2 raised to minus 3. By that way, you can make this sequence, and you can expand this sequence in way you can easily convert this 1101 binary into a decimal number, right? So you can further calculate all those examples. You can do little bit practice. The main part is the to learn the method. So this particular method is very simple. Of any base numbering system, if you want to convert into a binary numbering system, you have to take likewise weighted positions. Like if you want to convert any base 4 numbering system into decimal system, you have to make it the LSB or LSB, that is the least significant digit, with the 4 raised to 0, 4 raised to 1, 4 raised to 2, 4 raised to 3, like that particular sequence you have to follow before the point and after the point, like 4 raised to minus 1 and 4 raised to minus 2, if you want to convert any numbering base system into a decimal numbering system. You can further check the convert this 22 octal number into decimal number. You can see as the base is 8, so you have to follow this particular series. Same way 121 hexadecimal number, if you want to convert into a decimal numbering system, again you have to follow the same method. So for any base numbering system, if you convert into decimal, the method is same, right? You must have to start with the particular base number positions like 8, if it is octal to decimal, then 8 raised to 0, 8 raised to 1, 8 raised to 2, and so on. If it is a hexadecimal to 0, then 16 raised to 0, 16 raised to 1, 16 raised to 2, likewise, right? So further we have to convert this binary number into octal number. So check this binary number. So all those examples is for your practice. So while you are watching this video, you also take the notebook and pen and you start do the conversion of all those numbers into a different numbering system. So our first example is the convert following binary number into octal number, right? And you know, in octal number you have a specific series of the binaries 1 1 1 0 1 0 1 1 1 and 0. So from LSB to MSB you have to take the group of 3 bits. Like first group is 1 1 0, so that is represented in form of octal is 6. Then 1 0 1 represented in form of octal is 5. 1 1 0 represented in form of octal is 6, and 0 0 1 represented in form of octal is 1. So my answer is 1 6 5 6 in an octal. Right, same way 1 5 7 3 octal you have to convert into binary. You know the rule is 3 is represented in form of 3 bits of binary in form of octal, and you can further 1 5 7 3. So we will start with the 3. So 0 1 1, 7, that means 1 1 1. 5 corresponds to 101 in octal and 1 corresponds to 001. So by that way you can also convert from octal to binary and vice versa. Right, now this particular octal number 64.175 you have to convert into binary. The rule is same. Make the group of 3 bits and you can convert vice versa. Right, again this particular number, example number 4, this particular binary number you have to convert into a hexadecimal number. Now this way you have to take the group of 4 bits and you can easily convert this binary number into a hexadecimal number. So if you take the group of 4 bits, like you can observe the binary series for example number 4, and you can take the group of 4. So it's like first if you start with the LSB position to MSB position, like first digit is 1101, it is represented in form of D in hexadecimal number. 1110 is represented in form of E in hexadecimal number. 0011 is represented in form of 3 in hexadecimal number. As such, the number is 3ED of hexadecimal number. Likewise, you can convert this particular hexadecimal number, example number 5, A748, into a binary equivalent number. Right, again each digit is represented by 4 bits in a binary numbering system, so you can convert likewise. So go through all following examples. Like example number 6, convert that particular octal number into hexadecimal number. Now you can observe the example number 2. You have to convert into a binary, right? So binary number you already have. Then that particular octal number you have to convert into hexadecimal number. So this is what a good practice, that octal number again you have to convert into a binary, and then binary you have to take the group of 4 bits and you can convert into a hexadecimal number. Same way example number 7, the particular hexadecimal number you have to convert into octal. So this is what a good practice of binary, octal and hexadecimal. You can make a interconversion between each numbering systems. Like 725 octal number you have to convert again into a decimal. That's only one rule, that you have to follow any base with the corresponding weighted position. Like this here 725 is, you can convert into a binary form. So you can also have the binary form, and that binary form again you can convert into a decimal, or directly you can go for 8 raised to 0, 8 raised to 1 and 8 raised to 2, like that way. So based on that numbering system, further we'll have a more examples, like based on that binary number you have to convert into a decimal number. So this is one of the example is that 10101.0101 binary number you can convert into a decimal, making 21.3125. So these methods are very much easy. You do as much as practice you can do. Like 567.32 octal number you have to convert into a decimal by using the same method. Same way this particular hexadecimal number AB34.F8 hexadecimal number you have to convert into a decimal number. So make enough practice of all this numbering system. Further we can convert the same decimal number into a binary, octal and hexadecimal. So this is one more pattern of asking the example is like 125.125 decimal number. Again you have to convert into a binary form, octal form and hexadecimal form. So based on our further discussion, like you can convert this 125 again divided by 2, and you can make this particular binary sequence as part of the remainder. So from that you can take from bottom to top and make this particular series. Same way, after point 0.125, you have to multiply by 2. So you can see this 0.125 is multiplied by 2. The answer is 0.25. This 0 you have to stretch out and make it your one of the bit is 0. Same way, further 0.25 again multiply by 2. 0.25 again multiply by 2. You have a 0.5. And this again 0 you have to take it out. Then 0.5 multiplied by 2 is a 1. So that 1 you have to take it out. So your this sequence is from always top to bottom. So this is like that arrow source. So my complete answer of 125.125 decimal number into a binary is 1111101.001, right? Like that way you can convert this particular decimal number into a binary form. Like same number you can convert into octal form. So you already know the binary form. You just take the group of 3 bits. Same way for hexadecimal, you just take the group of 4 bit and you can easily convert. But directly if you want to convert this decimal number into octal number, you can see the method is same. 125 again you have to divide by 8 till the answer becomes 0 and you have to take it out, the remainder out. And then those particular remainder you have to take from bottom to top, and that sequence is 175. So you can see here 125 decimal number is converted into a octal is by making the 175. Again after point you have to just multiply by 8 and you can take it out the 1 here. So my answer is 125.125 of decimal number into 175.1, right? Likewise, you can convert hexadecimal number the same method. 125 you have to again divide by 16 till the answer becomes 0 and you have to take it out the remainder. So from again bottom to top, my answer is 70 and again multiply by 16 you can make a further calculation. So 125.125 of decimal number you can convert into 70.2 of hexadecimal number. Further, one more example we will discuss, like 225.225. You have to convert into a binary, octal and hexadecimal number. So again you can do more practice, because 225 again you have to divide by 2. 0.225 again you have to multiply by 2, and by that way you can make a complete or finish the complete calculation. So this is again for your practice, and you can go through all this too. You can check all the values again, do the little bit practice and just go through it. So our main aim to is just learn the method how you can convert decimal number into binary, octal, hexadecimal, and vice versa. How you can convert hexadecimal number into a octal, into a binary and decimal number, right? So in between you can convert the internally conversion of numbering system. Like again 225.225 you have to convert into a octal number. Method is same, and once you follow the same method you will find the result is 341.16314 in octal number, right? So same number again you have to convert into hexadecimal number. You can go through all the process and you can easily find the answer with the same method. So we will not much discuss about it, but you can just observe the following example and you will see this, right? Now based on that, you should understand how we can convert one numbering system into another numbering system. Now why we learn this numbering system? Because your microprocessors, digital electronics, digital system can only understand the binary numbering system, which is the language of 1 and 0, right? So it's a either plus 5 volt or 0 volt. So those signals are called discrete signals. Now octal is one more representation of binary numbers. It is one layer ahead of the binary system. Hexadecimal number is also one layer ahead of the octal numbering system, right? So as long as you want to make your computers or microprocessor system fast, you have to take more number of ones and zero. At the same time you have to process it, right? Thank you dear students. This is about the digital systems as well as the different numbering systems, right? If you have any query, please discuss with me. Thank you very much.